Hi everybody, Matt Morgan here. In this lesson we're going to talk about energy and changes of state and work some problems from Wiley section 11-5. So we'll talk about strategies for solving heat problems. We'll go over the exercise from the reading 11-5b and finish up with Wiley homework problem 11-75. So Chem 2 involves a lot more number crunching than Chem 1, a lot more numerical problems.
No!
If you're not a math person, don't despair. Solving these problems is a learned skill, and the more you do it, the better you will get. It may take some time and other aid, but you can get this. So both the reading and the homework problems are really good examples. And one piece of advice we can give for working these problems is keep track of your units. Your units are very important. This is very much like the dimensional analysis problems that you worked in Chem 1. Look at your target unit, look at the units you're given, and then look at how you get from your given to your target unit. Let's work those examples now. So Wiley exercise 11-5b. It's from the Assessing the Objective for section 11-5. The problem states or asks, what mass of ethyl ether can be melted with 1 kilojoule of heat energy? And they want us to refer to table 11-2. The problem is about melting, so we're going to use the heat of fusion. So let's look at that table. There's 11-2. We need to look at the information for ethyl ether. Its heat of fusion is given both in calories and joules per gram. Because the question gives us kilojoules, we'll go ahead and use the 92.5 joules per gram. There's our problem again. So the target unit is grams. We are given kilojoules, and one of the conversion factors we will use then is the 92.5 joules equal 1 gram. That is the heat of fusion. We're also going to convert kilojoules to joules. So let's set up our dimensional analysis table. Our target unit is grams, so we're going to put that 1 gram on the top and the 92.5 joules on the bottom. We do this because we're looking at our target unit. Our first conversion, 1,000 joules over 1 kilojoule. Then our given 1 kilojoule of heat. Joules cancel. Kilojoules cancel. Our units that we're left with are grams. We multiply numbers on the top. We divide numbers by the bottom. And we get 10.8 grams for a final answer. So 10.8 grams of ethyl ether is melted with 1 kilojoule of heat. And we put our final answer in 3 significant figures. So let's do that homework problem. It's Wiley problem 11-75. It's from assignment 11 QB. So the question asks, how many kilocalories are released when 24 grams of steam at 105 degrees Celsius is condensed and cooled to ice at minus 3.73 degrees Celsius? It also says refer to specific heats, heats of fusion, melting points, and heats of vaporization and boiling points tables. It also gives us the specific heat of ice as 2.0 joules per gram degree C or 0.492 calories per gram degree C. This is a pretty involved problem. So let's look visually at what is happening. Figure 11-17 in section 11-6 of Wiley has a table of heating for water. This is a heating chart. The homework problem 11-75 is this same process but in reverse. We're starting with steam and we're going to cool down to ice. Step 1 cools the steam from 105 to 100 degrees. Step 2 condenses the steam to liquid water. Step 3 cools the liquid from 100 degrees down to 0. Step 4 freezes the liquid to solid ice. And finally, step 5 cools the ice from 0 to minus 3.73 degrees. So each of these steps will involve a heat calculation. We're going to perform all 5 calculations, add up all the results, and that is the total heat released. In each calculation, the mass is 24.0 grams. So our first step, we're going to cool steam from 105 to 100 degrees C. Section 11-6.5 gives us the specific heat of steam, 2.16 joules per gram degree C. Our problem asks for calories, so we're going to have to convert this value. Okay, we'll take our 2.16 joules per gram degree C. Our conversion from joules to calories is 1 calorie equals 4.184 joules. Our joules cancel, and we get 0.51625 calories per gram degree C. That's what we will use in our calculation for steam. Going to carry extra digits, we'll round to 3 significant figures at the end. So the heat released by the cooling steam, 24 grams, our specific heat that we just calculated, and 5 degrees, cooling from 105 down to 0. Our grams cancel, degrees C cancel, our final units is calories, which is what we want. We multiply our numbers on the top. We get 61.95 calories. We'll write that down. And that's how much heat is released when the steam cools. Let's work the next step. The second step, the steam condenses to water. It's a constant temperature process. Section 11-6.4 shows the heat of vaporization of water, once again, in joules per gram. We're going to have to get another conversion to calories. So 2264 joules per gram, our same conversion, 1 calorie equals 4.184 joules. Joules cancel, and we get 540.15 calories per gram. I recommend you go ahead and pause this video at intervals, work this calculation yourself. You don't want to just take my word for it. Also, if you look in the reading, you'll see that 11-6.4 says 2260 joules per gram degree C. Well, that gram degree C is incorrect. Vaporization and condensation is a constant temperature process. They work an example right afterwards, and it shows the 2260 joules per gram. So if you see that for vaporization, joules per gram degree C, the degree C shouldn't be there. So the amount of heat released when the steam condenses, 24.0 grams times 540.15 calories per gram, gives us 12,963.6 calories. That's quite a bit. In the third step, water cools from 100 degrees C down to 0. The specific heat of water is 1 calorie per gram degree C, so this calculation is pretty straightforward. 24 grams, 1 calorie per gram degree C. Our temperature change is 100 degrees C. The amount of heat released is 2,400 calories. Step 4. The water is at 0 degrees. It now freezes to ice. Table 11-2 gives the heat of fusion of water, and it gives it to us as 79.8 calories per gram. Nice to not have to convert that. 24 grams, 79.8 calories per gram. Multiply those two together. We get 1,915.2 calories. One step to go. We'll cool our ice from 0 degrees to minus 3.73. So this is just like the cooling in steps 1 and 3, but we'll use the specific heat of ice, and that's given in the problem, 0.492 calories per gram degree C. 24 grams, 0.492 calories per gram degree C, a temperature change of 3.73 gives us 44.04 calories. So we have the values for the calories released in each of our 5 steps. Now we'll add them up, find the total. Step 1, the cooling of steam was 61.95 calories. Step 2, steam condensing to water, 12,963. Step 3, the water cooling. Step 4, water turning to ice. And step 5, the ice cooling to minus 3.73 degrees C. Let's add all those together. Might want to pause, use your calculator. I get 17,384.79 calories. We're not quite done, almost, because the question asks for the answer in kilocalories, so there's one final conversion. So 17,384.79, 1 kilocalorie over 1,000 calories gives us 17.4 kilocalories. We'll use 3 significant figures for our final answer. And we are done. That was quite a problem. Individually, not too bad, but it did require...
Wow, okay, so that was a tough problem. As you work it and you think about assessments, you are not going to see a problem with all 5 parts strung together on an assessment. There may be a couple of these calculations, 2 or 3 that you string together. That's fine, but you won't have to do all 5 parts. The thing to remember on this is work each part individually and add them together for each step, because they're going to want to know the total amount of energy that's released or absorbed. And you will be given information like specific heats and heats of vaporization. Don't worry about having to memorize those. And finally, most importantly, the main job of your course mentors is to enable your success in these courses. You can email us at the group inbox at chemistry@wgu.edu, or you will find contact information for your individual course mentor in your course of study.